Okay, so welcome to my channel on managerial economics, and in this particular video, I'm going to teach on multi-stage games and game theory. So please, if you have not watched the videos on game theory, please, it is 5 videos in the series, so you can watch the first, second, third, fourth before you come to this video, because that will yield a better understanding. Once you've not watched them, you cannot get much understanding from this, right? And please do well to subscribe, share, comment, and let us have your feedback as well. Now, in this particular video, this video is part 5 of the series on game theory. And this video, I'm going to teach about sequential move games, because in all the former videos, I've taught extensively on simultaneous games. So in here, when we talk about sequential move games, here there's always a leader and then there's always a follower. So here, one player makes the move, the second player studies the move made by the first player, then he also makes a move. All right. So here they don't play it simultaneous, but rather they play it sequential. One makes a move, then the second one observes the move of the first one and also makes his move. Now, representing a sequential game in a diagram is called an extensive form. Okay, representing a sequential game in a diagram is called an extensive form. So in this particular game, we can see that firm A is the leader. All right, firm A is the leader. Because one he plays, firm B will play given what firm A has played. So firm A is the leader, firm B is the follower. So if firm A plays up, okay, given that, firm B can also play up or down. On the other hand, if firm A plays down, okay, given that firm A has played down, firm B can also play up or down. That is why we have to represent it in like a probability tree, like given that. So it means that we have to represent in a probability tree. So in this particular table, if firm A plays up and firm B plays up, firm A gets 10, firm B gets 15. If firm A plays up and firm B plays down, firm A gets 5, firm B gets 5. Okay. So what this simply means is that given that firm A has played up and firm B plays up, this is what will happen. Given that firm A has played up and firm B plays down, this is what will happen, right? Okay. Also, if firm A plays down and firm B plays up, firm A will get 0, firm B will get 0. And if both of them play down, firm A gets 6 and firm B gets 20. All right. Now we have to examine the Nash equilibrium. Remember that Nash equilibrium occurs when none of the players have incentive to move from that point. So let's look at up as a Nash equilibrium. Like let's examine whether up is a Nash equilibrium. So up, 10, 15. Now at this point, let's examine whether any of them have incentive to move. So let's first of all examine whether B has incentive to move. Now, if B moves, it now becomes up, down, because here we are, remember, the first notion here is for A and the second is for B. So if B goes down, it now becomes up, down, okay? That means that B would have reduced his payoff from 15 to 5. He will not do that, so he will not move. Okay. Let's see if the same thing will happen to A. Now they are at up, okay? If A moves down, it now becomes down, up. Remember that always the first item is for the leader, and the second is for the follower. Now in down, up, A gets 0. So if A moves from this equilibrium and A chooses down, it now becomes down up. That will mean that A will decrease its money from 10 to 0. So here we clearly see that both A and B, when they are at up, none of them have incentive to move and leave the other. All right, so A and B achieves a Nash equilibrium at up. Because at up, if you move alone, you lose. No matter whether you are A or B, you lose if you move alone. Now let's examine up, down, up, down, up, down. Now, if they are at up, down, and B decides to go up, it now becomes up, okay? Then B would have increased his money from 5 to 15. That means this is not a Nash. Because Nash, when you move alone, you will not benefit. But when we are at up, down, and then B moves alone to up, it now becomes up, and then B will benefit. So it is not a Nash. So that one is out. Again, let's examine the third scenario where we are at down, up here. Down, up. Now at down, up, if B moves to down, it becomes down, down. And B would have increased his money from 0 to 20. So it is not a Nash. Nash, if you move alone from that point, Nash, if you move alone from that point, you cannot benefit. Let's also check that for A. We are at down, up. We are at down, up. If A moves to up, it becomes up. So A would have then increased his money from 0 to 10. So this definitely is not a Nash. At Nash, when you move alone, you will not benefit. Let's check the last one. Now, if we are down, down, okay? If we are down, down, if B alone moves to up, it now becomes down, up. So B would have reduced his money from 10 to 0. He will not do that. Again, if we are at down, down, and A decides to go up, it will now read like up, down. So A would have reduced his money from 6 to 5. Okay, down, down, and down, and up, down. He would have reduced his money from 6 to 5. He will not do that. So since both of them will not unilaterally move, it means that this is also a Nash equilibrium. Nash says that no player will, if a player moves unilaterally, he will decrease his payoff, right? So both of them are Nash equilibrium. So here we have two Nash equilibria, right? We have two Nash equilibria. We have two Nash equilibria. Okay, so we don't have only one Nash equilibrium. We have two Nash equilibria. That is the plural, Nash equilibria. Okay. However, one of the things I want us to know is that whenever we have two Nash equilibria, only one of them is the best one. Okay, only one of them is the best one. How would we know which of them is the best? We will use what we call the first mover advantage. The first mover advantage. That is what we use to examine which of them is the best Nash equilibrium. So here, if I'm player A and I play up, I know that definitely player B will not play down because player B will not leave 15 and come for 5. So if I play up, there's no way player B will play down. He will also play up because he will not leave 15 and come and take 5. Okay. Now, if I play down, there is no way player B will play up because he will not leave 20 and come and take 0. All right. So the lesson we learned here is that the first mover will engineer the first step, then the follower will follow. So if I'm player A and I'm the first mover, I'll do what is best for me because if I know if I play up, player B will definitely play up. And if I know if I play down, he will definitely play down. I'll play up because 10 is better for me than 6. All right. 10 is better for me than 6. So I'll play up. All right. So that means that the best Nash equilibrium between the two is this one, when they all play up. All right. And that is referred to as the subgame perfect, the subgame perfect, the subgame perfect, right? So all the explanations I've made, this explanation in the slide, this explanation I was making, okay, this explanation I was making. So the explanation here is in the slides. We can look at it, right? So if you want the slides, if you are watching on YouTube and you want the slides, you can just send me an email and I can get them to you. Okay, but of course, all the explanations I'm making is in the slides, the same thing. So you can just look at this slide and look at the next one. You get all the explanations I'm making. Okay. Now, in the jargon of game theory, the Nash equilibrium, where we have 6 and 20, is not the subgame perfect. All right. Let me just go over the slides. Let me just go over for the purpose of the record. So remember that Nash equilibrium is a condition describing a set of strategies in which no player can improve her payoff by unilaterally changing her own strategy, given the other player's strategy. So therefore, when we analyze all the 4 situations, we know that we will have 2 Nash equilibria, that is up, up, and down, down, like what I was showing earlier. However, remember that firm A is the leader and he'll choose what will favor him in these 2 Nash equilibria. In a first scenario, if firm A chooses up, B will have no incentive to play down. Therefore, the outcome will be 10 for player A, 15 for player B. In the second scenario, that is the down, down, if A chooses down, B will have no incentive to choose up. B will definitely choose down. And the outcome will be 620. Now, given this, because A has the first mover advantage, A will go for the first scenario because for him, 10 is better than 6. All right. So the best out of the 2 Nash equilibria is to play up, up. And that is called the subgame perfect equilibrium. Subgame perfect equilibrium. Okay, that's the best out of the 2 Nash equilibria. So subgame perfect equilibrium is okay. Sorry about that. So subgame perfect equilibrium is number 1 when we have a Nash equilibrium, and number 2 when each stage of the game, neither player can improve her payoff by changing her own strategy, right? So in this scenario, the only subgame perfect equilibrium is when player A chooses up and player B chooses up, right? For better understanding, let's solve a second example. Now, in this example, suppose that 2 firms are playing a sequential move game. Based on their market structure, firm A is the first mover, whilst firm B is the follower. If both firms decide to increase advertisements, firm A will earn a profit of 2. Firm B will earn a profit of 5. Remember that firm A is the leader, firm B is the follower. Also, if firm A decides to increase and firm B decides to decrease, firm A will earn 5, firm B will earn 2. If both firms decide to lower or decrease the adverts, firm A will earn 6, firm B will earn a profit of 1. However, if firm A decides to decrease and firm B decides to increase, they will break even. Represent the above game in an extensive form and determine the subgame perfect equilibrium. Okay. So firm A is the leader. So we have increase and decrease. Remember that the question says, and so we have firm B here, firm B here. Okay. Remember that if both of them increase, the question says that firm A will get 2, firm B will get 5. If firm A increase and firm B decrease, firm A will get 5 and firm B will get 2. Okay. So if both of them decrease, the question says that firm A will get 6, firm B will get 1. And if firm A decrease and firm B increase, okay, if firm A decrease and firm B increase, firm A, and the question says both of them will break even. So we have 0, 0. None of them will get profit. Now let's examine the Nash equilibrium. Let's start with increase, increase. So when we are at increase, increase, and firm B moves to decrease, firm B will decrease. I mean, if we are at increase, increase here, and firm B decides to choose decrease, firm B will decrease his payoff from 5 to 2. He will not do that. Again, if we are at increase, increase, right, and firm A decides to go to decrease, so it will now become decrease, increase, he reduces his money from 2 to 0. He will not do that. So this is one of the Nash equilibrium. Okay, let's assume we are at increase, decrease, that is here. Let's see if any of them has incentive to move. So if we are at increase, decrease, definitely firm B has incentive to move to increase, because he will increase, or he would, sorry, it's like we are using the word increase, increase. Don't worry, just follow what I'm saying. Firm B, if he goes to increase, it's now the increase, increase. That will mean that he will get 5 instead of 2. So he will move. So this is not a Nash. Nash says that if you move alone, you will not benefit. But here, if we are at increase, decrease, and firm B alone moves to increase, for it to become increase, increase, he will benefit. So this is not a Nash. Let's examine this one too. 0, 0. Decrease and increase. Now, if we are decrease, increase, okay, and firm B moves to decrease, becomes decrease, decrease, he will now get 1 instead of 0. He would have benefited. So it is not a Nash. Let's examine that for firm A. Firm A, we are now at decrease, increase, okay? If firm A increase, holding B at increase, it will now become increase, increase. And firm A would have now gotten 2 instead of 0. So he will move. And given that B is held constant, so this is also not a Nash. Nash, if you hold one person constant and you move alone, you will not increase your payoff. Finally, let's examine this. Now here, let's examine this. Now here, we realize that at this point, if we hold firm A at decrease and firm B goes to increase, firm A and firm B will reduce his payoff from 1 to 0. He will not do that. Again, when we are decrease, decrease, right, and firm A decides to go to increase, holding firm B at decrease, it now becomes increase, decrease. And firm A would have reduced his money from 6 to 5. He will not do that. All right. So this is a Nash. Nash says that when you hold one person constant and the other moves, he will decrease his payoff. And we have done it for the 2 of them and realize that when that happens, either of them will reduce his payoff if the other person is held constant. So this is also a Nash. So we have 2 Nash equilibria. Now, let's determine which of them is the perfect. So now we use the first mover advantage, all right? So if I'm the first mover, if I know if I play increase, there is no way B will play decrease. B will play increase, definitely. And if I know that when I play decrease, and of course, I should know that when I play decrease, there's no way B will play increase, because for him, 1 is better than 0. So I can either engineer this as a leader or engineer this as a leader. So for me, between 2 and 6, 6 is better. So I will play decrease. Once I play decrease, the second player will also play decrease. That means that the best out of the 2 Nash equilibria is to play decrease, decrease. And that is the sub-perfect game, all right? So this will bring us to the end of our discussion on game theory. So game theory have 5 videos in the series, all right? So kindly subscribe to the channel, share, like, comment, and let us have your feedback. but much more importantly, subscribe to the channel. All right, so this will bring us to the end of the series on game theory. Thank you.